Welcome. This is the video of Mrs. Neller's algebra notes, and these are the notes for section 1.1 called Variables in Algebra. Our objectives today are to evaluate a variable expression, to use the distance equals rate times time formula, and to find the perimeter and area of a shape. Now, in algebra, we use letters to represent numbers a lot. And they can represent one number or more than one number. And a variable is a letter that is actually used to represent a number. So when we're using a letter to represent a number, we call it a variable. And that variable can be uppercase, it can be lowercase, it can be a Greek letter. So it could be X, it could be Y. You've seen pi, that's a variable that stands for 3.14. It could be the Greek letter sigma that stands for summation. So there's lots of different letters that we use in algebra. And the value is the number that that variable is representing. So when you say x equals 5, then anytime you see the variable x, it has a value of 5. So 5 would be the value of x in that case. A constant is just a fancy math term for a number, any number. So constant is just a new vocabulary term that you have to be familiar with. And when you put variables and numbers together, it's called a variable expression. And it's a collection of constants or numbers, variables, and then mathematical operations. And the mathematical operations are, of course, adding, subtracting, multiplying, or dividing. And when we put numbers and variables together with those mathematical operations, we get an expression. So it could be something like 3 times x. Or it could be y minus 15. Or it could be something even more complicated, like 3 times x plus 15 times y. So there's a lot of different ways that we can create a variable expression in algebra. And this is what we're going to explore more of today. Now, before we get into evaluating mathematical expressions, we need to make sure that we understand the meaning of the expressions. So here we have 4m, 4 dot m, that dot stands for times, and then we also have 4 parentheses m, and then you close the parentheses behind it. So all of these expressions mean 4 times m. So these are 3 different ways that you can represent multiplication. Sometimes students get confused when they see a number and a variable right next to each other. So you need to make sure that you remember that that means multiplication. Sometimes that little dot is between the two of them, and sometimes it's not. But it still means multiplication in either case. The next set of expressions we have is C and then a line and 10, or C divide 10. And both of these mean C divided by 10. So the operation that is going on here is division. Now our last 2 expressions are fairly straightforward. We have y and then a plus sign and then 5. So that means pretty much what it says, y plus 5. So the operation that's being performed here is addition. And then our last expression is 19 minus w. So again, it's kind of like we're translating exactly what is written there. 19 minus w. And whatever w would be, that's our variable that has a value that we don't know what it is yet. And here the operation is subtraction. So these are the types of expressions that we're going to see in the rest of our notes, just like here in example 1. So here we want to state the meaning of each expression and name the operation, just like we did in the chart. So this first example here, part A, we have a 13 and then a plus and then the variable x. So that's exactly what it means. 13 plus x, whatever x is. X could be 8, x could be 800. We don't know that yet. But the operation here is definitely addition. Part B has 14 and then the fraction bar or the division symbol and then x. So this means 14 divided by x. And again, x is our variable. We don't know what the value of that variable is yet, but our operation is going to be division. Part C, this is where we have the number and the variable written right next to each other. So just like we had up above in that first part of our table, that is dealing with multiplication. So this means 17 times x. So our operation here is multiplication. And in part D, again, this is fairly straightforward. We have x as our variable and then a minus sign and then 11. So that's exactly what this would translate into, x minus 11. You could also say is 11 taken away from x. That would also be a correct way to state the meaning of that expression. And the operation is going to be subtraction. Now, when you evaluate a variable expression, what you're really doing is substituting the value of the variable into the place of the variable. And then you simplify the expression as much as you can. So now they're going to tell you what the value of the variable is, and you're going to put that number in the place of the variable and then do the mathematical operation. So in example 2 here, it says to evaluate the variable expression when y equals 3. So there they tell you what y equals. So in part A, I have 12 times y. So if I wanted to rewrite it with that little dot in there, I could. That little dot stands for times. It's a fancy way to write multiplication now. We don't want to write multiplication with an x anymore because that could look like a variable x. So we're going to use that little dot. Or we can know that the number and the variable are right next to each other, and that means multiplication. So now my next step is to substitute the 3 in for the y. So this is really 12 times 3. So now they've told me the value of y. I know what y is. So now I can do 12 times 3 is 36. And there I get an actual numerical answer when I simplify and evaluate the expression. So for part B, we have 45 divided by y, but y isn't y is 3. So I'm going to substitute 3 in for the y, and then I can actually do that calculation. I can do 45 divided by 3, which is 15. So when I evaluate and simplify that expression, I get 15. And for part C, our last one here, this is 9 minus y, or 9 minus 3, which is 6. Notice that I'm not using equal signs here because these are expressions, not equations. Equations have equal signs, but not expressions. Now we're also going to use a lot of math formulas, and here are just 4 examples. We will use these, we will use more than these. This is just an example. We have distance equals rate times time. You should be familiar with that. This is perimeter equals 2 times the length plus 2 times the width. So that's finding the perimeter of a rectangle or a square. This formula, area equals length times width, that's area of a rectangle or a square. And here we have area again. Area is 1/2 times the base times the height. That's the area of a triangle. So for example 3, they tell you what formula they want you to use. And a formula just has more than one variable in it. And we're going to substitute in the values that they give us for certain variables, and then we'll solve for the other one. So in example 3, we're using our distance equals rate times time. It has it in lowercase letters, but that's okay. And we're going to use that to find the distance traveled by a truck moving at an average speed of 65 miles per hour for 3.5 hours. So when we read word problems, we have to make sure that we break it down and understand every part. So first of all, we're finding the distance. So that means I'm going to be solving for D. Now this is a truck. That's okay. We're not really going to worry about that. But here it says it has an average speed of 65 miles per hour. Now speed is the same as rate, and R is the variable that stands for rate. So here we're going to be finding our distance, and the speed is our rate. And here we know our time as well, 3.5 hours. That's how long the truck drove. So I always like to rewrite the formula, distance equals rate times time. And again, you can put the little dot in there for multiplication if you'd like. Now we're finding the distance, so I'm going to be finding D. I know my rate is 65 miles per hour, so I'm going to substitute 65 in for R. And my time is 3.5 hours, so I'm going to substitute 3.5 in for T. And now I'm going to actually do that calculation, 65 times 3.5. Remember, you can use calculators, so if you don't remember how to do that on your own, it's okay. And we're going to get 227.5. Now remember, for word problems, you also need a label. And if we're finding distance, we've got hours up here for our time, and we had miles per hour. So that must mean my distance is miles. So I substituted in the two values that I knew for the variable of rate and the variable of time, and then I was able to find the distance. So the truck went 227.5 miles in 3 hours. We've got example 4 and example 5 left, and then we're done. Example 4 deals with the perimeter of a shape. And in part A here, we have a triangle. And to find the perimeter of any shape, you basically just add up all the sides. And you can use a special formula or just write it out. So what we're going to do here then to find our perimeter, P is used for perimeter, so we're going to add up all our sides. We're going to add up 9 and 12 and 15. It doesn't matter what order you add them in. You can use mental math to add them up or use a calculator. But when you add them, you will get 36 feet. Remember, the label for perimeter is just the units. We don't square it or cube it because it's not area and it's not volume. So it's just 36 feet. Now this example part B is a pretty funky shape. It's got 1, 2, 3, 4, 5 sides. So it's a pentagon. But again, it doesn't matter how many sides there are. It's still perimeter, and we're still just going to add them all up. And you can add them up in any order you want. But we'll have 16 plus 9 plus 7 plus 15 plus 20. So again, you can use some mental math here. You could say I have 20 plus 15, that's 35. And then you could add another 16 and then 9 and 7. So you can go out of order if you'd like to and do mental math to get your total. Or add them up on your calculator. Either way, you're going to get 67. And again, our units is just going to be meters. So this is helping you review the concept of perimeter. And it's helping you substitute values into a formula. Our last example then deals with area. And area formulas have a lot more structure. They definitely have more variables. And in part A, we have the shape of a triangle, and we know the formula for the area of a triangle that was in our notes earlier, and that is area equals 1/2 times the base times the height. So for perimeter, we just kind of added up all the sides and made our own equation without really using too many variables. But here, if we're finding the area, I'm going to substitute in my value for the base and then my value for the height. The base of the triangle is the bottom, so that's going to be the 11.2. The height is how tall it is, so that's going to be the 6. So I'm basically taking 1/2 times 11.2 times the 6. And remember those little dots there, that means times. Now you can change the 1/2 to a 0.5 if you'd like, but your calculator can also do fractions. So when you type this into your calculator, you should get 33.6, and this is inches squared, because the label for area is always squared, because you have two measurements that you're multiplying together. It's inches times inches, so that's inches squared. Okay. Our last example then, this is a rectangle, and again we have a formula for the area of a rectangle. It was in our notes earlier as well. Area equals base times height, or area equals length times width. Either one will get you the correct answer. It just depends on how you want to think of it. So if we use the base times height one here, our base value is 9. So that's going to be the value of our B variable. And the height is 8. So that's going to get substituted in for our H variable. And then 9 times 8, I hope you know that. I hope you don't need a calculator to tell me that that's 72. And again, it's going to be centimeters squared. So it was centimeters times centimeters, so that was centimeters squared. And the last slide here has your homework or your practice problems. Remember that the E stands for even. So there are certain spots in your homework where you don't have to do all the problems, you only have to do the even ones. I know it looks like a lot, but it's not really that much. Don't be intimidated by it. Good luck. Do well.